Okay, we are in Objective 6 for Unit 4 in Honors Math 3, and we are learning how to graph rational functions in this lesson. Now, there are multiple things that must occur as we're graphing rational functions, and one of the first things that we do need to deal with is we need to find the asymptotes that go with the rational function. And the asymptotes are kind of like the framework for the graph. Another part that's really important is intercepts, so x-intercepts and y-intercepts. So these first three, we're not going to graph, we're just going to practice finding those beginning things again. Okay, now vertical asymptotes, we find them by looking for the zeros in the denominator. They have to be real zeros, so we're not worried about the imaginary zeros. It needs to be a zero that doesn't get reduced, and then it is possible to have more than one zero in the denominator. So it's possible to have more than one vertical asymptote. Okay, so vertical asymptotes, VA for short. By the way, vertical asymptotes, vertical lines, x equals. Now, zeros in the denominator, factored form in the denominator is very handy. So x times x plus 2. What makes it 0 in the denominator there? 0 and negative 2. They don't reduce. So x equals 0, x equals negative 2. There are two vertical asymptotes for this particular function. Yes, it's possible to have more than one. Now, make sure that you have the equation of the asymptote. If you just say 0 or just say negative 2, enjoy missing the problem. The horizontal asymptote, HA for short, we take the limit as x goes to infinity. Now, we're not even going to show the work. If we take the limit of 1 over x squared plus 2x as x goes to infinity, that's bottom heavy, and bottom heavy is always 0. But again, equation of a line, and HA equals 0 does not cut it, or just like up above, VA equals 0 or VA equals negative 2, that does not cut it. So horizontal line, that is in the form of y equals, and the limit of this as x goes to infinity was 0. That was pretty fast finding the asymptotes. Let's remind ourselves real quickly how we find intercepts again. Any point on the x-axis, the x is something but the y is 0. And any point on the y-axis, the x is 0 and the y is some value. So if I want to solve for the y-intercept, I just plug in 0 for all the x's. Okay, so we get y equals 1 over 0. Oops, 1 over 0. They can't equal an undefined value. Okay, what's going on here? Well, that is telling us that the y-intercept does not exist. Now, why does that make sense that the y-intercept does not exist? Well, remember our vertical asymptote? One of them, x equals 0. X equals 0, isn't that the y-axis? So that's the vertical asymptotes are the nothingness of the graph. The graph doesn't touch cross anything vertical asymptotes. So it makes sense that there is no y-intercept. Now if I want the x-intercept, we plug in 0 for the y. 0 equals 1 over x squared plus 2x. Now, how can a single fraction equal 0? Only if the numerator equals 0. Can 1 equal 0? No. And so there is no x-intercept for this. I mean, if we tried cross multiplying, we get 0 equals 1, and that's not true either. There's no x-intercept for this one. So there's no y-intercept, there's no x-intercept. Okay, let's pick up some speed here on the next one. Okay, vertical asymptotes. Zeros in the graph. Negative 3, x equals horizontal asymptote, limit as x goes to infinity. It's equally weighted, 1 over 1, y equals 1. Okay, y-intercept. Okay, x's are 0, so y equals negative 5 over 3, 0, negative 5/3. X intercepts, plug in 0 for the y. How can a fraction equal 0 if the numerator equals 0? So x equals 5, or 5, 0. Okay, let's try the next one. Vertical asymptotes. Let's see, it looks like factoring. So 2 times x squared minus x minus 12. 2 times x minus 4 times x plus 3. Okay, and so 4 and negative 3. Now, let's just double check and make sure that they don't reduce. So x minus 4, x minus 2. And so I'm noticing that the x minus 4s reduce. So when they reduce like that, it is not a vertical asymptote. It's not a 0 that's still in the denominator. So the only 0 that we still have in the denominator is negative 3. So the only vertical asymptote we have is x equals negative 3. Okay, now, horizontal asymptote. Horizontal asymptote. Now, if we take the limit as x goes to infinity, now we could do the original problem or we could do the reduced problem. So equally weighted, 1x squared over 2x squared, so y equals 1/2. Okay. Now, one caveat here, horizontal asymptotes, or even any asymptote, little caveat here, there must be at least one x, or whatever the variable is, in the denominator after reducing for there to be any asymptotes. So in other words, if we were to reduce, and so like for example here on number 3, if the x minus 2 reduced, and let's say it was x minus 2 down here in the bottom as well, and there were no x's left in the denominator, then there would be no asymptotes at all. So there has to be at least one x left in the denominator for there, after reducing, for there to be any asymptotes. Okay, now the reduced equation, I know I did mention this. When we have this reducing thing going on, that is a removable discontinuity situation, a hole in the graph where the limit exists. And so there is a hole at x equals 4. Specifically, it's at 4 comma, look at the reduced equation. If we plugged in a 4 now, 4 minus 2 is 2 over 2 times 5. So 2 over 2 times 5, so 1/5. There's a hole at 4 comma 1/5. Okay, x intercept, y intercept. We work with the reduced equation now. So x intercept, doesn't really matter whether you do the x intercept first or the y intercept first. So the x intercept, plug in 0 for the y, 0 equals, work with the reduced equation and focus on the numerator, because the only way a single fraction equals 0 is if the numerator equals 0. So x minus 2 is still in the numerator, equals 0. So x equals 2. Okay, y-intercept. If we plug in 0 for the remaining x's, I get negative 2 over 2 times 3 which reduces to negative 1/3. Okay, kind of cramped for space a little bit here, but anyway, moving on. Now we're going to do all that same stuff, but then we're going to do the sketch of the graph that goes with it. So, sketching the graph, f of x equals x minus 3 over x plus 2. So, let's, first off, does it reduce? No, we don't need to factor. Vertical asymptote, x equals negative 2. That's the 0 in the denominator. Horizontal asymptote, does the limit exist as x goes to infinity? Yes. 1 over 1, so y equals 1. Okay. Y-intercept, if I plug in 0 for the x's, I get negative 3/2. And x-intercepts, if I plug in 0 for y and focus on the numerator, x equals 3. Okay, so now, how do we do this with the graph? So, vertical asymptotes, x equals negative 2, vertical line, but it's the nothingness of the graph. So we do a dotted line when we're doing asymptotes. So x equals negative 2, y equals 1, also a dotted line. This is not the actual graph, this is the framework of the graph. Okay, now, however many vertical asymptotes there will be one more piece of graph than there are vertical asymptotes. Okay, so there's one vertical asymptote, there's going to be two pieces of graph. There's going to be a piece of graph to the left side of the vertical asymptote, there's going to be a piece of graph to the right side of the vertical asymptote. But let's plot our x and y intercept right now. So 3, 0, and negative 3/2, so negative 1/2, or 0, negative 1/2. Okay, now something else to consider as we go to the infinity. So as we go far out to the left and right, it will go to the elevation of the horizontal asymptote. So as we go to the left and the right, it's going to be going to elevation 1. The only question is, does it go to elevation 1 from the bottom side, or does it go to elevation 1 from the top side? Okay, now let's take a look at the right side of the vertical asymptote here first. So since I have a couple points here, I think it's pretty obvious that we are coming to the horizontal asymptote from the bottom side. Okay, we label the intercepts. So negative 3/2 for the y-intercept, positive 3 for the x-intercept. And now, over here on the left-hand side, we don't have any x-intercepts. We have, the only x-intercept we had was over here on the right-hand side. So over here on the left-hand side, there's no x-intercept. So could I start from down low, close to the vertical asymptote, and go to elevation 1 as I go to the left? No, I'd have to cross the x-axis. So I must be coming from up high and going to elevation 1 from the top side. And there's our first graph. Let's try the next one here. Hopefully I won't get any more phone calls. So vertical asymptotes, well, factor x minus 2, x plus 1. Okay, so does it reduce? No, none of them reduce. So x equals 2, x equals negative 1. So x equals negative 1. X equals 2. Okay, take the limit as x goes to infinity. It's bottom heavy, so horizontal asymptote, y equals 0. Now, all we're going to do is just out the ends of the x-axis, because that, by the way, that's where y equals 0, elevation 0. So that's the horizontal asymptote. Okay, now let's do the y-intercept. If I plug in 0 for all the x's, I get 0, comma 1 over negative 2, or negative 1/2. And if I plug in 0 for the y, 0 equals the fraction. Can this fraction equal 0? No, because the numerator will never equal 0. So there is no x-intercept. Now, a lot of times when there is no x-intercept, it's a little bit more challenging because we have to plug in some other points. But let's start in the middle section here. In the middle section, we never ever touch or cross vertical asymptotes. Okay, so that means that in this middle section, it has to stay between the vertical asymptotes. Now, could we be going from low to high or high to low? Or could we be going from low to low or high to high? Here in this middle section, it's one of those 4 shapes. But remember, no x-intercepts. And we have a y-intercept below the x-axis. So because of that, no x-intercepts and a y-intercept below, we must be doing a low to low shape of some sort. Okay, and label intercepts. Okay, now out on the sides, it does have to go to elevation 0 from either coming down low, close to the vertical asymptote, or coming from up high. And could I be coming from up high, going to elevation 0 out here on the right? Yes. Could I be coming from down low, going to elevation 0? Yes. Either one's possible. So now as you do more of these, you'll probably have a better idea about which one it is, but we just have to plug in a point. So plug in something to the right of this vertical asymptote, so like 3. We plug in a 3. Now the top is 1 no matter what, so 3 squared is 9, minus 3 is 6, minus 2 is 4, so positive 1/4. So we're above at 3, so therefore we must be coming from up high and going to elevation 0 as we go out to the right. Now we're going to do a similar thing out here to the left, so plug in something like negative 2. So if I plug in negative 2, now negative 2 squared is positive 4, minus a negative 2, so 4 minus a negative 2, that's at 6, minus 2. Again, you're positive, so we're above, so we must be coming from up high, going to elevation 0 as we go out there to the left. Because as you go to the infinities, it goes to the horizontal asymptote elevation, because that's what we were doing when we're figuring out the horizontal asymptote. We're taking the limit as x goes to infinity. Okay, so 2 more problems that we're going to go ahead and do. And hopefully it starts to click in a little bit better now. So number 6, so we want to get it in factored form. Okay, so x plus 3, x minus 1 it looks like. And GCF of 2. Kind of cramped for space. Of course, I did it to myself. I'm left with x squared minus 2x minus 5. That actually is not going to factor anymore. So really, we're just left with x squared minus 4x. Oh, I was mistaken. That will factor some more, won't it? So 2 times x squared minus 4x minus 5, that will factor again as 2 times x minus 5 and x plus 1. So maybe it's why it's a good idea to go ahead and factor it and show all the steps. Okay, so does anything reduce? No, nothing reduces. So there are 2 zeros in the denominator, negative 3 and positive 1, so x equals negative 3, x equals positive 1. So negative 3, positive 1, Okay, if we take the limit as x goes to infinity, it's 2. Okay, so y equals 2 for the horizontal asymptote. Okay, and if I tried plugging in 0 for the x's, I'd be left with negative 10 over negative 3, which is positive 10/3, 3 1/3. So up about right there. And if I plug in 0 for the y, we get 0 equals the numerator, because that's where the x-intercepts show up. And we can see that we get 5 and negative 1. So 5, 0, and negative 1, 0. Now, by the way, when we do have x-intercepts, and I didn't mention this before, but the bounce cross stuff that we learned back in polynomial functions, that still holds true. So this one right here, this was x minus 3 to the first. So odd multiplicity, it went through. Okay, now don't try to apply the other high to low, low to high stuff that goes on. That doesn't work in this unit. But whether if the multiplicity is odd, it will go through the x-axis. If the multiplicity is even, it will bounce. So keep that in mind. These are both odd multiplicities because they were both x minus 5 to the first and x plus 1 to the first. So they're both going to go through. So we've got negative 1. It's going through. And we've also got positive 5, 1, 2, 3, 4, 5, and it's going through as well. Okay, now, and let's keep in mind that the graph has to go to elevation 2 as we go out to the left and the right forever. So let's look at the middle section here first. Now I've got an x-intercept down here, it goes through, and I've got a y-intercept up here. It is possible to touch or cross horizontal asymptotes. If it happens, it generally happens somewhere pretty small numbers, for sure at least between negative 10 and positive 10. So this one appears to be crossing. We must be doing some kind of shape that's looking a bit like, let me get a different color here, doing it a bit like this. Remember, it never touches or crosses vertical asymptotes, and yet it keeps getting closer and closer to them. It does pass the vertical, the overall function at the end does pass the vertical line test. Okay, now out here on the right, I have to be going to elevation 2 as I go to the right forever. And I have an x-intercept right here, and it goes through too because the multiplicity is odd. I must be coming from down low and going through and going to elevation 2 as I go out to the right forever. Okay, now out here to the left, could I be coming from down low and then going to elevation 2 as I go out to the left forever? Well, wouldn't I have to cross the x-axis? Yes, and there were no x-intercepts out here. Therefore, I can't be coming from down low close to the vertical asymptote. I must be coming from up high close to the vertical asymptote. And I know it's kind of crowded. Sorry, trying to save paper. Let's label the intercepts. This one's negative 1. This one was 10/3. And this is 5. And that's a full credit graph. Okay, last one for this notes, and yes, I'm sorry, the notes are a little bit long. The good news is that these notes actually work for, there's 2 assignments, so there's assignment 6A and there's assignment 6B, because we know you need a little bit of time for this to sink in. So really this is the notes for 6A and 6B, and you're only doing the 6A assignment right now. But then you get some more practice on the 6B assignment using the exact same stuff. So number 7, again, let's get it in factored form. So we've got x minus 3, x plus 2, and I've got x minus 2 and x plus 2. And we notice that the x plus 2's are in common, And so they reduce, which means we have a hole at x equals -2, but more specifically, -2, now if I plug in the -2 to the reduced equation, I get -2 minus 2 on top, so -4 over -2 minus 3, so -4 over -5, which is positive 4/5. There's my hole. Okay, let's go on with the other stuff. We have vertical asymptotes. Well, what didn't reduce? X minus 3. So x equals 3 is my vertical asymptote. Horizontal asymptote. Do I still have x's in the denominator? Yes. What's the limit as x goes to infinity for the reduced equation? 1 over 1, so y equals 1. What else do I have happening? I have x-intercepts and y-intercepts. So if I plug in 0 for the y and looked at the reduced equation, x equals 2, so 2 comma 0, because x minus 2 is the only thing that didn't reduce, so if I set that equal to 0, 2 comma 0, its multiplicity is 1, so it goes through. And the y-intercept, if I plug in 0 for the remaining x's, the reduced equation, I do get -2 over -3. In other words, I get positive 2/3. So putting all that together, I've got x equals 3. I've got y equals 1. We've got 2 comma 0. We've got 0 comma 2/3. As I go to the infinities, I have to go to elevation 1. So since I have my points here on the left-hand side, I think it's pretty obvious we have to be coming from down low on the vertical asymptote and go to elevation 1 on the left side from down low. Okay, so let me get a different color here. So coming from down low. Now your final graph needs to pass the vertical line test. So make sure you're not curling away from the vertical asymptote. I do see some students sometimes they start getting a little bit lazy or a little bit artistic. Don't get lazy or artistic with it. Just make sure it's actually following function form. That point over there is 2/3. Okay, now to the right-hand side, we have no x-intercepts. Since we have no x-intercepts, could we be coming from down low and going to elevation 1 as we go to the right? No. So therefore, we must be coming from up high and going to elevation 1 as we go out to the right. And there is my last graph. So now you guys get to practice this on worksheet 6A. And as I already mentioned, there is a worksheet 6B. Just because we know you need to practice this some more. It's kind of hard to get it all in just one assignment.